Robots and Agentic AI session. So I'm Hao Huang, a senior developer advocate from Hong Kong. So please allow me to introduce another speaker for this session, Cyrus Wang. Yeah, Cyrus, many of you may know Cyrus. He's our senior AWS hero and also from Hong Kong. And maybe you have likely to see Cyrus actively to participate across many social media platforms. And this session we will bring to you today related to two of the most popular and important technologies and fields, robots and agentic AI. So this is our agenda today. I will first give you an overview of agentic AI, considering that maybe you may not be the expertise or experience in agentic AI developers. So to ensure that everyone we are all on the same page, I won't start by introduce AWS services, but rather begin with some predictions about the future of agentic AI from top-tier investment institutions. Then I will hand it over to Cyrus, and he will detail how to combine large language models and robots together to build amazing real-world applications of agentic AI on AWS. So let's begin by examining the future trends of the agentic AI. If you dive deep into the evolution of generative AI, you will see that it follows a clear progression, with each phase bringing new priorities and challenges for business. So on the left, we see low agency systems which are rule-based and require high human oversight. And on the right, we see high agency systems that can operate independently and even make strategic decisions. But in reality, in 2025, today, we are still at the very beginning stage of agentic AI, and reaching the right high agency requests maybe not only just the technologies, but also some guidance or some governance and trust, or even some organization readiness. So although we are still in the very early stage of the agentic AI, let us envision a future world powered by AI agent. I would like to recommend this one is from the Sequoia Capital's keynote address at AI Ascent 2025 in San Francisco, which is also referenced here. Sequoia Capital predicts that the future AI systems will go beyond their current tool-like attributes and evolve into autonomously operating intelligent agents. And these intelligent agents will have the abilities for reasoning, for planning, collaboration, and high autonomous operation. And the most striking aspect of the Sequoia Capital's prediction, I think on the right, is their vision for the 2030s agent economy. It will operate like a global neural network and composed of numerous agents forming an interconnected network, as illustrated on the diagram on the right. So these presented a tremendous opportunities for all the developers today, so you can position yourself at the critical nodes within this vast global network, so thereby become essential components of the emerging economy network. So Sequoia Capital also made a bold prediction in their keynote addressing the upcoming emergence of the first one-person unicorn. So it is a company created and operated by a single individual with a valuation of $1 billion. So future founders will no longer build traditional teams, but instead of collaborate the workflows of AI agent. So in this evolving landscape, the founder's primary roles will transform into something like to maybe decide which functions should be automate, or which to delegate, or at which point critical human insight need to be integrated in the whole network. So additionally, if you look closely on the diagram on the left, stochastic mindset, which is my favorite concept, the emergency world of AI agents require us to adapt entire different ways of thinking. That is why That was why in 2025, you may already know about Kiro. We have some spec-driven development in Kiro to help a human being to control the AI or the large language model to do the works following the rules by our human beings. But it's another topic where I for the time limited, I'm not going to dive deep in the Kiro part, but I want to notice these features it originally come from the stochastic mindset. We should adjust our mindset, not only the technology, but our mindset as well. Okay, so in 2025, we also see that much of the foundational infra for the future world of agentic AI is already under construction. For example, communication protocols. So during the development of the internet, the TCP/IP protocol laid the foundation for network interconnection. Similarly, in the emerging era of agentic AI, AI agents also require interoperabilities, both where they're within their own tools or within other AI agents as well. So you can see there emerging standards such as MCP and A2A are addressing these challenges and have already gained adoption from many industry leaders, including Amazon, Anthropic, Meta, and Google. So this protocol facilitates connection between AI applications and models and various resources, such as data sources, tools, memory, repos, and other services. So rather than having each application developer create their own connections, I think MCP and A2A can help us to the service provider can implement some standard protocol to let them interact seamlessly. So notably, I want to mention is AWS actively participates in the standards communities for both the MCP and the A2A projects. So contributes AWS decades of experience in distributed systems and to enhance this protocol. Okay, so the complete AWS Agentic AI portfolios is here. It composed architecture with some supporting systems. So from the bottom to the top, you can see these services are organized into 3 layers: the infra layers, the AI and agent development software layers, and the application layers. So each layer contains more specialized service categories. So in Cyrus' upcoming presentations on robots and large language models, a small portion of this portfolio service will be covered. For example, like using Emerald Rover Sonic for voice interaction, using Kiro for spec-driven development, and using Emerald Rover Pro models, and AWS IoT services, and so on. So if you have even great ambitions, so you're welcome to use this portfolio as a guide to explore the broad new world of agentic AI. So this concludes my part for today. So thank you all for your listening. Next, I will hand the time to Cyrus.
Okay. Can you everyone hear me? Okay. Thank you very much. Let me a little bit background about our project. First of all, I'm coming from Hong Kong, and this project is my student project. We are working together. My institution is called the Hong Kong Institution of Information Technology, and we are a technical college, not university. And here is the actual robot and also the girl. They help us to working on the project. So that's help him. And they are all the AWS Educate ambassador. And this is our STEM project. Everything is open source. And let me show some demo for you guys. And first of all, maybe just show the video first. Can you hear? Yeah. We can actually, I can't bring the actual hardware come here. I can't take it. And we can control drone, humanoid, and robot dog. Everything is controlled by IoT and the LLM. And one of the demos is just for fun. They are dancing. And this one is Nova.
Hello. My name is
we integrate the Nova into the humanoid, and then the ambassador, student ambassador, AWS student ambassador, they can talk to them, and then the robot is automatically do the action themselves according to the conversation.
Of course, I'd be happy to answer any questions you have about AWS
Their action
services.
is something like that.
What would you like to know?
What is AWS EC2?
AWS EC2 or Amazon Elastic Compute Cloud is a web service that provides
let me show another
compute
one.
capacity.
This one is interesting. For Nova implement into the robot, they have mic, they have speaker, they can talk to each other and they do action. Terminator.
Hello, I'm doing great. Thanks for asking. I'm here to assist you with any tasks or questions you have. How can I help you today? I'm glad to hear you're doing great. If there's anything specific you need help with today, whether it's a task or a question, feel free to let me know. I'm here to assist you.
Behind the scene is like that, just a browser inside there, just one a browser inside the robot. And then the MCP server will control it.
Feel free to reach out anytime.
Hello, how are you? This one is the digital human integration. But this is not using Sonic. We are using another Nova Pro to the streaming, another API in Cantonese. So sorry, this Cantonese we will not serve for the local people. And you can talk to her and whatever you like. And behind the scene, the Nova have the grounding. Okay, so it's able to answer anything, even though the today weather, today's stock price, whatever they can. And also through the MTC server, all of the robots still able to voice control it, ask them to do the high-level instruction.
HKIIT 修讀 IT 114115雲端系統及數據中心管理高級文憑，我對雲端技術同埋 AI 有濃厚興趣，仲喜歡探索新知。運動一
Yeah, we jump at it. This is ask them to do an exercise, whatever they like, 4 step, anything. 4-step exercise. We don't have the other is 4-step exercise.
3. 所有機械人快速向後行。4. 所有機械人向右轉。所有動作已經。
It's okay. And let me show you some. I will try the live demo. If it is not work, say sorry to first. Live demo. And due to we don't have the actual robot, but we have a simulator. This is made by COI. Okay, and just for everyone. Okay. Hello, can you hear me? Sorry, not yet kick it. Hello, can you hear me?
Hello. Yes, I can hear you. How can I assist you today?
Okay, help me ask all robots wave their hand. Oh,
All the robots are waving their hands.
technically have some issue. I just skip it. Try it later. Okay, let's go back to the slide and just quickly skip that one.
No problem. Let's go back to the slide.
Still talking. Wait, I stop it first. don't. Yeah, they can help us to do the presentation. Okay, now we're talking about the architecture. This project is very, very cheap, first of all. Since we don't have any server at all. The whole system is based on the serverless architecture. I use AWS, Lambda, App Runner, and behind the scene, the AI, everything is on top of Bedrock. And we will explain the flow one by one. But the overall, we have different channels. We have the ROI channel, we have the digital human channel. It is through the through this one. This is another service. Okay. But what is the difference between before we using Novasonic? I have built a lot of similar applications before, but it is very, very difficult to make it like a human. Okay? But as the problem is that if you use a traditional method, you're streaming the speech to text, and then put the LLM convert the voice again. This is a walkie-talkie style. This is request, response. Main issue, you can't interrupt. You can't suddenly say, stop. It will not respond. But now using the Sonic Nova, this is stream in, stream out. And then also the function calling, the tools calling, also stream in, stream out. And this is the main difference here. Is I can't make without Nova. Here is the Sonic speed stream interaction workflow. Just extract the high-level architecture diagram. For the human, we are just open the browser. You just see it, open the browser. And then we talk to it. We use the web shortcut for the app runner, but this is downgrade version, not the full power version. Since there's some limitation, but it still works very well. And we use Cognito to do the authentication. We can control login, log out. And then the app runner use IAM to call Bedrock, and then Sonic model. And this is streaming. Over the streaming, before every prompt, we have a DynamoDB to give some background context. Every robot have their background, have their name. You can talk to them. They will have different response, different action. Since we have the background set up over the DynamoDB. And then we will call the MCP server hosted in Lambda. Okay? We will show you the source code, how to run MCP server in Lambda. And behind the scene, the MCP server source code is very, very simple. We are just a simple wrapper to all of the action for the robot, robot dog, humanoid, drone support. Just wrap it up. And then it will pass the tools call result into the AWS-IoT command sent to the robot. And the robot will execute another Python built-in in the hardware to execute the action run by run. Okay, but it have the intelligence. As the Novasonic, let me try later. It's supposed to be able to, you give the very high level instruction and then produce a lot of interesting action, not just a command. Okay, a little bit about tools calling, but somehow I think maybe a lot of people well familiar with it. If you are using an LLM without tools calling, it's just a checkbox. But now how we control everything, whatever we like, is that the Sonic model also be able to do the tool execution to call our MCP server and then check out the IoT. And one of the very interesting things is that you have the problem that how many tools call they can have. Answer is infinity. Since you are talking about using a streaming model, it will not stop. So you can have a single action, a single command or single instruction. They can do a lot of action. Yeah. Here is our source code. At the end of it, somehow is code talk. Okay, this is my source code about how to create the MCP server within Lambda. This library is AWS. It's very simple. You just install PIP, install the library, and then mainly you need to have the create a handler here, and then you have the MCP tools register the high level, mark the tag. Then you can create the MCP server. But next slide will show the detail. This is the magic. Just say like your MCP tools, and then write your function as usual. Okay, then you can wrap it into MCP server, and then the Lambda is a MCP server. But one of the reminder is that we build it up like this. We better use enum. Okay, use enum to make sure that, for example, you are very difficult to your user voice to tell the robot name accurately. You want it to become more accurate. If you have experience in Amazon Lex, in the past we have built in a chatbot, also have some idea. We have the slot value. You just fix some value to them. They will improve the accuracy of the action. So use enum. Okay, here is the second part of the source code, and this talking about we will have the IoT client. I'm not sure are you familiar with IoT, but simple, I can say that it is extremely simple. If you want to control something, not say about robot, whatever you remote, you want to remote something, even though your computer, you just put in certification there, run a small program, use very little memory, and then you have the long-term connection channel so that you can send something, connect with it. We just have the connection of IoT, and then we want to, here's the Lambda. Lambda will send the action into the AI service, and the service will downgrade to send to the robot. Basically, our application is very simple. We just send the tools name. Okay, the tools name include robot go forward, robot dog sit down, something like that. Jump take off. Yeah, this is just use the function name to break the action. You can also try to send the parameter into your MCP server. It will work very well. But for our use case, we are not really useful to have the parameter. For example, a robot go forward 4 steps. It may not work very well, so we just go forward. If you want to go forward 4 steps, let the LLM call 4 times. 4 steps, 4 times. Okay, and we want to try to make sure the action more parallel. Say everyone do together. Since the IoT is, if you use the in sequence loop to call it, you will see the robot one by one to take the action. But parallel it, map it, it will done. Okay, here is the client-side source code. It's so short. I just extract the key part, and you can use Kiro to generate it 100% work. And just a very simple one. The red color highlight is the handler. You receive the command from MCP server. I just proposed in the IoT service. I just capture the on-purpose receipt, and then under here, just deserialize the JSON object. I can get the tools name. The tools name I mentioned, go forward, robot go forward, turn right, turn left, something like that. And then the robot will, our robot will trigger according to the hardware configuration, so that our application is able to extend to any kind of hardware with support Python. We don't have to have serious migration. Very simple. We can apply to different robots. And for the deployment, if you're interested in our project, it's quite simple. Everything is a CDK, everything. We deploy the backend. We just deploy a Lambda function. No more. This is doing the MCP server. But we have some permission set up. I need to show you. This is using the Lambda, the Python function module. This is beta one, but very stable. I say that. I always use the beta one from CDK. Somehow it's quite stable. and just build the Lambda function and just set the permission for 2 IAM. One of the IAM is that we need to let the Lambda function to call the AWS IoT topic. And the topic is every robot got one topic so that it will not corrupt together. Robot 1, 2, 3, 4, 5. For the all case, it's just call all of them. I saw the source code, so the map is doing that. And that's the reason why we have the permission here. And I don't want to make it simple as possible, as this is not a public service. This is a Lambda function called up by another Lambda function or app runner. So I don't need API gateway under this situation. I don't have to protect it too much. So I just directly using the Lambda function URL and then just give them the right, say, look like use IAM. I will show you how to use IAM to authenticate the MCP server. I have some source code modification. And for the CDK, and then you need to grant the function who able to call the MCP server. Okay, you need to set it up who able to call it. Actually, we have two kinds. One is the voice channel. One is the text channel for the digital helmet. But for CDK, you can't duplicate the name. So we have the numerical increment here. For the MCP server, this is the client. This is something I can't find it, but maybe this is already maybe depreciated. As now we have agent core. When I build this project, there's no agent core at all. That's the reason why you may think about agent core. If you don't use agent core, you use my way. I want the IAM authentication into my IAM server. At this moment, there's no built-in driver. So I need to modify the request header to inject the STS token into it. It will work normally. Okay, but at this moment I can't find the built-in library to support the IAM authentication. And what I am doing is just here, just do the transport protocol and then get the token and then inject into the HTTP header. And then the application will become using the IAM authentication from my Lambda function to call the MCP server Lambda function. Since this is a Node.js example application, I need to do something to extract to convert the MCP server tools setting as I need to log in. I extract it one by one, the tool's name, and then register it myself in Node.js. After some tests, this is our experience from Nova. What happened from the Nova Sonic? Why sometimes they not calling the tools? Not call. I said they say I let the robot go forward already, but actually they didn't call it. How can you make it? And then I check the document. That's magic parameter. Remember it. The name I don't think is good. Suppose it's not any. If you set any, it will call the tools first. Okay, this is a magic keyword. Supposed to be not say any. You can think that this is not any. That's a mandate. That's somehow to enforce tools call. Is any. Okay, you check the document. This is something surprising me. At the end, we need to register the tools and then have some basic code set up so that the Sonic model be able to have the proper configuration on the API call. And then it's actually better than it's a JSON. Okay, whatever source code here, it generates JSON and then into the request parameter. And register the tools so that they know what tools they have. But using the tools, the Sonic Nova is not able to call it. It just return the function name and parameter to you, and then your source code supposed to be called it. And this is not direct MCP server call, so I still have to register the function and then wrap it up and call it myself. Here's my poem. It's not really very complicated. Just a robot command assistance. You have a tools. But something I do think is amazing, as we got a lot of tools. I surprised us. Wow, we got more than 40, not 14, 40. A lot of tools. Go forward, turn right, turn left, jump, go forward, robot go forward, robot dog go forward. Every type of hardware have their own tools, but although it's very similar, but we need to do it. We support a lot of tools. But one of the enhancements is that logically, you don't need to list your tools in your prompt. But we found that if you list it in your prompt, it will much better. Okay, so that you see the last source code, last line is that tools, available tools is listed out. Just list it out. And we have something tested is that it will lie to you, or all robots will lie to you. You just say, you need to tell them that if you can't do it, just don't do it. All LLM is like that. You need to tell them, otherwise it will say, hey, I have already do it, but actually he is not doing it. Okay, so that's the second line. Hey, you can't do it, don't do it. And finally, I don't know if this our Asian speaking is bad, it's not good. We can't say jump take off. I would say jump take off, he will know that jump take off, boom take off, whatever, they will recognize something wrong. Oh, so my head is that I send everyone, including me and my student, I'm not able to always tell him correct. I just write a second line, the last line, jump, similar, and then jump take off. Okay. And here's the combined source code. I just mentioned, we have some background. Every robot, we have a name, have a background story, how old he is a man or a woman, whatever, they have a story behind the scenes, this is inject here, so that they will be able to answer something very interesting. And also, we need to list out the tools. I say that list out the tools will improve your performance. Don't save token, just list the tools. And this is our prompt. Okay, we have another workflow behind the scenes. This is not the Sonic one. Okay, this is the Pro one. Since we have another solution, I show you the digital girl. It's another service we buy from other vendor. Since we need to handle Cantonese, listen Cantonese, speak Cantonese, and we can't do it. We must buy some service. And we have the digital girl. The digital girl API is supposed to be not the streaming. Okay, not voice. They need test, but test streaming. Okay, test model streaming. But be honest, the Sonic model will much feedback faster. Under this case, you know that we have a chances between two models. One is language model, one is really language model, not large regular Cantonese model. Okay, and then this is with some delay and not bad, not good at Sonic. The logic is that we just have this time we use an API gateway. Okay, this time we use API gateway, and then we just have the voice input or text input through the API gateway, and then this time it's not app runner. Why we need to use app runner in the previous design? Since it's that app runner support the website, can do the streaming websocket. Otherwise, you lambda, you will break the NIE before. Okay, you can't do it. And then also use the SIM connector to log in, log out, to remember the member. And we share the SIM MCP server. We share the SIM MCP server to control the robot. About the background, I just mentioned they also have the background and in DynamoDB. And here is a bedrock and then the model. And IoT, okay. In our situation, multi-agent will make your system more smart. But for robotic control, if you behind the scene is in multi-agent style, it will too many conversation, the delay you are not accept it. I don't want, we found it's difficult to do it. So we try to one shot, everything one shot, and just using the framework to handle it. Okay, one of the challenging if you're using the raw API is that we do have this kind of problem. Okay, the prompt is include a lot of tools. And also you need to analyze it. For example, push up, sit up, and then turn your hand 5 times. It means 5 times cold calling. Okay? Not a raise a hand one with a parameter. We do need here, I said you send 5 calls. If you're using the raw low-level API to do it, you will not be able to handle a lot of tools calling by default. But using framework, it will be able to help you to do it very easily. Now I just, before we have very complicated implementation, but I don't want to mention here. Before I low-level program, I just extract all of the action, ask the LLM to become a comma separated list, and then we extract the action and then send to the robot. This works, but not stable. Okay, not stable. Since comma separated, you can have many comma separated, but this is not well. And then we do think about what should do we next. Oh, finally, we just found that, if we just using Kiro to help us to migrate our low-level source code into high-level source code, it solves everything. It's so interesting. It's behind the scene is that this one is very important, the loop. Behind the scene, the agent. The built-in agent, strat agent built-in, there's a tool selection and then reasoning and tools calling loop. This loop is always running. So what is the meaning? You can have infinite number of tools call. Solve everything. We just put in a very complicated instruction or very high-level guideline to our robot. They will think about it and then generate a sequence of tools call, and then they call themselves. I don't have to care about it. This is the beauty of the, if you have very simple application, don't use the low-level API. Directly to use the strat agent framework. You will gain the benefit. You don't have to care about the problem happen later. Okay. Here's our prompt. For the test control, we're supposed to have the background. Yeah, as similar, you will have the background, the robot name, the robot story, and then we also list down the device here. Supposed to be more accurate. You can help. It will be helpful if you put in the system prompt. This is a high-level instruction. You can somehow, if you found, basically our experience is that if you found something, they are not very accurate. You just put them explicitly in system prompt. It will be helpful for you to improve the accuracy. And then we just have to say that, we have some default case. We want to control everyone. Or if you don't mention which robot, which dog, which drone, we just assume it's all. This is our design. We want to all. And somehow this is how we handle all. Okay, just a description. If you like handle all, and this is something you need to remind since the agent. They have, if they think this is not enough information for them to take the action, they will not do it. This is something we found. Oh, he say he do it, but actually he is not doing it immediately. So mark the immediately. Otherwise, it will wait for your more information or just delay it. They have some reason. Don't do anything. So the keyword immediately is the magic. It will trigger the call. Don't wait. Okay, and the last is just setting. It's not very simple. It's just some reminder. And also we want it to respond in traditional Chinese. So I don't want it. Even though I type in English, I don't want it to respond English. Since it's in Hong Kong, we are using Chinese. Okay, and the second part of the prompt, we do some example to them just, so that you will understand the API call. For example, go forward, it means all robots go forward. Otherwise, they will ask you, okay, they're so smart, they just ask you back, robot number 1 to 6, which one you like? But I don't want. I want go forward, then everyone go forward. That's our magic. Sit down, auto sit down. Similarly, every API call for different hardware, we give some example to them. Is it the OS that handle like that? And okay, this is not serious. It's okay. Executive immediately remind them again. Yeah, here is our Strat agent Nova code. It's very short but very powerful. We just need to create the agent, and this is generate from the hero. Okay, I do something very stupid. I git code the hero source code into my folder, and then I ask them read all of them, and then help me rewrite, and then they rewrite it for me. And when you're using hero, remember, when we're using the Strat agent, remember you need to provide the memory. Okay, since it's an agent, you have some background agent. Agent need to remember what they are doing. So you need to provide the memory provider, and then put the prompt, and then since this is using the MCP server, it's quite straightforward this time. You just plug in the MCP server into the client, and then we'll be able to do it. But I have some source code, maybe not here, is that I also need to handle the IAM authentication. Since this is Lambda 1 call Lambda 2, even though you set up the IAM role, but you remember, you're using AWS SDK, you set up the IAM role, it's behind the scene, it automatically tell you to get the token. But this API called MCP server, remember MCP server is not from AWS SDK, your client, not Windows server. Okay, the server from AWS, but the client is your own, you create the MCP server client. It is not support AWS IAM authentication. You also need to do something like me to call SES to inject the header with the token to make it authenticate with IAM authentication. Yeah, since we want to make the system secure, we use AWS IAM everywhere. Okay, and about the IAM security, here is my source code. Previous one is Node.js. This one is Python. It's very similar logic, but Python is more easier for you to read. And we do need to have the MCP client call, but okay, let me take a look. The IAM part may not be here. Yeah, the IAM part may not be here, but the tools calling is still, you need to still call something MCP server and list it out, and then run it. Yeah. Okay. This is the source code from Strat agent, and the IAM security kind already do the application, but you want to call Python function, it's just like that. You Python agent code and then put it down, okay, and it solve everything. Quite straightforward. Why we have this kind of tools? In the past we have the mix-up tools. Okay, before the MCP server run, we have the mix-up version. We have the previous version is not MCP server. We can combine your MCP server tools with other tools together. You just, be honest, behind the scene, they actually create a JSON. You just update their API to append the list. You can combine different MCP server, different tools, whatever you like. So behind the scene, we have other servers. So we have this kind of logic. And I want to show you the demo again. Let me try. Okay. Actually, behind the scene, I have a project that implement. There is a six IoT client here, and I just queue them up. Whew. Let me try to run it again. Okay, this IoT server. Just wait for them stable. Double try again. Oh, Cognito login. and select all of our robots first, and then try the streaming again. Hello, can you hear me?
Hello? Yes, I can hear you. How can I assist you today?
Can you try ask all robots go forward? Go forward, not go for it.
The robot is moving forward as you requested.
I have something wrong in the IoT server. If this is working, you will see the command go through here and then see the go forward command. But this is not a real robot. It is mocking all the IoT server. So I need to reboot the client. But never mind, just skip here. And let me continue the PowerPoint. Sorry. But I still can show you this one. This one is made by Kiro. You can, I have no experience on 3D programming, but this one is generated by Kiro and connect with IoT behind the scenes. We can have the manual mode, for example, like that. Reset, okay, and then show panel. We can do something like that. Originally, I want to voice control them. But now I can't do it. For example, we can ask them to show some kung fu and left kick. Yeah, and also we can rotate, turn right. Yeah, but this one is not working. If this one working, it's supposed to be voice control. I can't stop them. Control-Shift P.
It seems like you're encountering issues with the voice.
It is sent to wrong people do everything. It's quite painful. Yeah, if you think about it, if you have the MCP server to connect with your hardware or whatever you like, and then you just start the Sonic, this is a real-time assistant in your office. They will listen to you and then help you do anything. Next time I will implement maybe control whatever I like in my office and then just open the Sonic and then let it do anything. Okay, I just go back to the PowerPoint. Next time. In the summary, my experience is that at the beginning, I just think about, I don't want to make something I don't use. I don't use a framework. I just, very simple, copy the standard source code. It worked. But when you debug and then face the next problem, this is no solution. Just lazy, don't lazy. Use framework. Okay, whatever framework you use framework, don't be lazy. Since the framework will already included the very common problem and solution for you. Don't have to think about it. Just use the framework first. And also, we have streaming API conversion. Okay, I'm very scared about it. Okay, the source code is very complicated. But at this moment, we have Amazon Q CLI or Kiro CLI. You just ask them to convert all of our API from the request response style into streaming. They convert it for me in very accurate result. And also, this is my experience. You see, I have a virtual girl. Yeah, the digital human. The digital human they have their own set of API I need to implement. And it's from China, simplified China document. I just download the HTML of the whole of the document and then put in the folder. Ask QSCLI, read all of them, and then help me implement the API. It worked very good, and then I don't have to do anything. This is my experience on using QSCLI. And also, you have the technical depth. The technical depth, maybe you see a lot of warning, a lot of improvement. You just, in the command line, run the pipeline and fix it. It will continue to update your source code, fix it, update your source code, fix it, and then the code base become very clean and look very nice. And finally, remember tools calling. This is our experience. This is by in sequence. Remember, tools calling in LLM is not in parallel. That's the reason why we need to implement all to our API. You ask all robot turn right. Actually, some tool calls like robot 1 turn right, robot 2 turn right, robot 3 turn right. They are doing like that. So that we need to have an all API and then use our own function call to do it in parallel. This is what our finding. Okay, finally, last slide. Hey, thank you very much. A little bit earlier. I'm sorry for the demo. Okay.